Hi, welcome back. This is Professor Ridge. We're covering section 3.2, solving by substitution or elimination. And again, this is just review from elementary algebra, but we'll kind of cover it just in case you forgot. So the first method, the substitution method. So let's look at exercise 8 from the book. I have the system 3y plus x equals 4 and x equals 2y minus 1. So for the substitution method, my first step is going to be so the first step is you're going to solve one equation for either variable, and it's your choice. You can solve the top equation for x, top equation for y, bottom equation for x, or the bottom equation for y. Your choice. Now for this problem, number 8 here, step 1's done for you already. This one's already done. This one's solved for x. So we'll make that our choice. I mean, I could have solved the top one for y if I wanted to, but why do extra work? Now your second step is to take the result of step 1 and substitute it into the other equation. That's key. So from step 1 we said x equals 2y minus 1. So we're going to take the other equation, 3y plus x, and we're going to take that x out and we're going to put in 2y minus 1 for the x. So we're going to rewrite the top equation. Equation 1 is 3y. We take the x out and we substitute in for x 2y minus 1. See, that's the key step. That's why it's called the substitution method. Alright, so now we're going to solve the resulting equation from step 2. Okay, so we're going to take this equation, 3y plus 2y minus 1 equals 4. We can drop the parentheses. We're going to combine like terms. Add 1. Divide both sides by 5. So y is 1. Now, we're not done because if you recall, what's a solution to a system look like generally, except for the couple of special cases? And if you remember, there are two lines that intersect. The solution's a point. And how do we write a point? A point is an x-coordinate and a y-coordinate, an ordered pair. So far we found y. Now what do we need to do? And hopefully you're saying you need to figure out x. So now our first step is we're going to take results. So now we're going to take the result of step 3, which is this y equals 1, plug it into the equation that we got from step 1. So the equation from step 1, which was done for us. And we're going to substitute this 1 in for the y. And we're going to solve that. So I guess you should say and solve for your remaining variables. So x is 2 times 1 is 2 minus 1, which is 1. And then this is not really a step, but I like to write it as one. You're going to write your solution. As a point. If it's a point. If it's a special case, state what it is. Write no solution, empty set, whatever. Or the line, all the points using the set notation. Okay, so our solution is the point 1, 1. And there you go. So let's try another one. Solve. Let's try... And of course we can change the letters. Let's try number 18 here. 4p minus 2q equals 16. 5p plus 7q equals 1. And remember, if the letters, it's alphabetical order, so p is the first one, q is the second one. So it's pq, unless we're told otherwise. Alright, so first step, solve one of the equations for x, or for p or q, doesn't matter which. And I'm looking at the top equation because the bottom equation, you kind of think ahead. If I solved it for p, I would have to divide by 5, which would get me a fraction. If I solve for q, I would have to divide by 7, which would get me a fraction. But on the top equation, I could solve for p or q, and I should be fine. Actually, q would probably be the best. So I'm going to solve, this is equation 1, equation 2. Solve equation 1 for q. So I got 4p minus 2q equals 16. I'm going to subtract 4p from both sides. I'm going to divide by negative 2 to get q by itself. So that's 2p minus 8. Okay, so that's step 1. Now, step 2, take that result, take the 2p minus 8 and substitute it for q in the other equation. So the other equation would be, here I'm going to write it up here. So step 2, I'm going to take the other equation, which is equation 2, 5p plus 7q. I'm going to take the q out, put in 2p minus 8. So let me read the equation again. 5p plus 7q equals 1. Be very careful. I substituted q as 2p minus 8. Now solve this. Step 3. So let's see, distribute the 7. Combine like terms. Add 56 to both sides. Divide by 19, both sides. So p is 3. So this was step 3. Now, step 4 is take that result, 3, p is 3, and plug it into the equation from step 1. So this equation here, which is q equals 2p minus 8, and we're going to plug the 3 in for the p and work that out. So that's 6 minus 8, which is negative 2. So that's step 4. And then step 5 would be my solution, step 4, which is the point. Remember, it's PQ, 3, negative 2. Now, I haven't been doing it, but I should. How do you check to see that this is the solution? Well, it's just like we started the first 3.1 is you're going to plug 3, negative 2 into both equations and see if it's a true statement. So if I want to check, I got to plug in 4 times 3 minus 2 times negative 2, see if that equals 16, and then do it for the bottom one also. 5 times 3, 7 times negative 2, does that equal 1? And I just punch it in my calculator. So I go 4 times 3 minus 2 times negative 2, it equals, and you get 16. 5 times 3 plus 7 times negative 2 is 1. Check, check. So I know I did it right. Exercise 24. It says solve using the elimination method. So on this one, the elimination method. So step 1, add the equations together, or add the multiples of the equations together to eliminate the variable. That's the goal, eliminate a variable. So if we look here, we'll call this equation 1, equation 2. If you add the equations together, and you just add down the columns, 2x plus x is 3x, plus y and negative y is 0, so those go away. And then 6 plus 3 is 9. So if we add them, just add the equations together, we get lucky and we eliminated the y and we just got 0 there. So normally you wouldn't write it, you just write 3x equals 9. So that's step 1. And we'll talk about the multiples in a minute. So our goal was to eliminate a variable. See, we eliminated it. And now we end up with one equation with one variable. So step 2, we know how to do that. We just solve the resulting equation. Oops. From step 1. So we're going to divide both sides by 3. So x equals 3. Okay, so step 3 now is take that result from step 2 and plug it into equation 1 or 2, one of the original equations, and solve it for the other variable. So step 3, so this is step 2. Step 3 is I'm going to let's take equation 1, which is 2x plus y equals 6. We're going to plug the 3 in for the x. Solve it for y. So y equals 0. So that's step 3. And then step 4 is, again, it's not really step, I just like to emphasize it. Write your solution as a point, unless it's one of the special cases. Okay, so what's our solution? X is 3, y is 0. Again, you can check it real quick. 2 times 3 plus 0, does that equal 6? Yes. 3 minus 0, does that equal 3? Yes. So it checks out. And I'm done. Alright, so let's do an example where we have to do that first step where you have to do a multiple. Now remember, our goal is to eliminate a variable. So if we look at number 32, I have 5x minus 7y equals negative 16, and 2x plus 8y equals 26. So if I just straight added these two equations together, (7x plus y equals 10), right? That doesn't help me. And why doesn't it help? And the thing is the goal is you want to eliminate a variable. So you're going to take, what you have to do is you decide which variable you want to get rid of. So first decide which variable you're going to get rid of. So I'm going to get rid of y. So let's say y. Okay. So now you're going to look at the coefficients. And find the LCD or LCM, it's like an LCD of those numbers. And what I'm trying to do is I need to multiply these by numbers that will be the same number, but one's positive, one's negative. So that's going to be, so LCM will be, I guess, 56. So now I know this is where I'm going. So I need to multiply equation 1. I'm going to multiply it by a number so that I get 56 for a coefficient of y. That's what I'm going for. So 7 times what is 56? Hopefully you say 8. So now I'm going to multiply everything in equation 1 by 8. So it's 40x minus 56y equals 16 times 8, 128 negative. Okay, so that's the multiple of equation 1. It's 8 times equation 1. And I want you to kind of get doing this notation too, so if you make a mistake you can see what happened. Oh, by the way, we're just going to cross that out. We're not going to do that. Now I want to get 56y. See, and this will cancel out and I get 0y. So what do I need to do to equation 2 to get a 56y there? And the answer is you're going to multiply by 7. And you got a golden rule, you got to do it to everything. You've got to do it to both sides, you got to distribute. So it's going to be 14x plus 56y equals 26 times 7. It's 182. Now I add these two equations together, going down the columns, 54x, the y's cancel. (182) or negative 128 plus 182, I subtract, that's 54. Okay, so that's step 1. So I eliminated y, I get this resulting equation, 54x equals 54. I'm going to solve it for x. So divide by 54. So x equals 1. So that's step 2. Now step 3. This was my step 1. Now step 3 is take that result, x equals 1, plug it into equation 1 or 2 to solve for y. So let's put it in equation 2. 2x plus 8y equals 26. Subtract 2 from both sides. It's 24. Divide by 8. So y equals 3. Y equals 3. And now I'm done. So my solution is the point x is 1, y is 3. And there you go. And again, I can check it real quick. 5 times 1 minus 7 times 3, does that equal negative 16? So 5 minus 21, yep. 2 times 1 plus 8 times 3, does that equal 26? So 2 plus 24, yep. So I know I did it right. Okay. That was page 2, I guess. Alright, let's talk about a couple special cases. Now, it doesn't matter what method you're using, whether you're using substitution or elimination, the idea is the same. So whenever you're going through the algebra, so let's look at number 14, doing the substitution method. T equals 4 minus 2s, and t plus 2s equals 6. And I'm going to solve it by substitution. So I'm going to take that t out, since equation 1 is solved for t, so that step 1's done for me. I'm going to put in 4 minus 2s for the t, drop the parentheses, combine like terms. So let's see, 4, the 2s's cancel. Now this is the thing, whenever you're doing with either technique, doesn't matter which technique, you're doing algebraic techniques, and this variable drops out, goes away, no variable in the equation. So if you remember before, if there's no variable in the equation, that means no matter what you choose for s, in this case, the statement will always be true or false. So you ask yourself, is that a true statement or a false statement? And if it's true, right, then it's always true, and you're going to get an infinite number of solutions, not everything, just an infinite number. And if it's false, you just write no solution, and you just stop there. There's no more work to do. Okay, so if it's false, you say no solution. And let's look at one that's true. How about number 40? This one's using the elimination method. And again, it doesn't matter what technique you're using. If you get a statement that's always false, then there's no solution. If you get a statement that's always true, then you say that the solution set, it's that case where they're the same line, so then you write the equation of the line for your solution set. So what am I looking for? Number elimination, number 40. So 8s plus 12t equals 16. 6s plus 9t equals 12. So let's get rid of s. So what's the LCB or LCM for 8 and 6? And you could do 48, but that's not the LCM, but that'll work. It just has to be a common multiple. So, but if you do the least common multiple, that keeps the number smaller. So that's 24. So I want to take equation 1, I want to get a 24 here. Equation 2, I want to get negative 24 here. So for equation 1, 8 times what is 24? And hopefully you said 3. So you're going to multiply everything by 3 in equation 1. And then now you look at equation 2, you want to get negative 24, so they cancel. So that's going to be times negative 4. You're going to multiply everything by negative 4. And as you see here, when you go to eliminate s, you eliminate both s and t, and 48 minus, and you get this equation 0 equals 0. So there's no more variables. And that's true. So if that's true, then that means there's an infinite number of solutions. It's that special case where they're the same line. So you're going to say, oh, these are not x and y. So it's a set of all s and t's, the points, such that, and write either equation down, doesn't matter, since they're the same. So that's the way you handle it in Math 90 now. So the solution set is the line. Remember, this is a line. Okay, so those are the special cases. Alright, that concludes the lesson for 3.2. Go to my math lab and try to do the exercises there. See you next time.